Did you know a simple cup of water holds secrets to Earth's most powerful weather phenomena? This unassuming container actually demonstrates global atmospheric forces on a tiny scale. Every swirling storm, every gentle breeze, mimics processes you can observe right here. Understanding this miniature world unlocks the mysteries of our planet's vast climate. Weather patterns are complex interactions of energy, moisture, and pressure across Earth. They dictate everything from daily temperatures to severe, destructive global events. But grasping these vast systems feels overwhelming without a tangible, relatable model. Imagine a cup as our miniature planet, exhibiting similar fundamental physical principles. This humble vessel becomes an accessible, immediate laboratory for atmospheric science. We can visualize evaporation, condensation, and convection within its confined space. These processes are the foundational building blocks of all large-scale weather systems. Understanding them helps predict and prepare for dramatic shifts in global climate. From gentle morning due to raging hurricanes, the same forces are always at play. The energy driving these changes originates from the sun, heating our tiny planet. This initial energy input sets off a chain reaction of atmospheric movements and transformations. Even seemingly minor changes within our cup can lead to profound, observable effects. Begin by heating the bottom of your cup, simulating the sun warming Earth's surface. Water molecules gain energy, becoming lighter and transforming into invisible vapor. This process, called evaporation, initiates the crucial transfer of heat and moisture. The warm, moist air then rises, just like warm air currents ascend into Earth's atmosphere. As this vapor rises, it cools, losing energy and becoming denser in the cup's upper regions. Wait until you hear how this cooling process forms clouds and drives rainfall. Eventually, the water vapor condenses back into tiny liquid droplets, forming a miniature cloud. You can often observe this as fog or mist clinging to the cooler inner surface of the cup. This condensation releases latent heat, further energizing the rising air within the system. These condensed droplets then coalesce, growing larger until gravity pulls them downwards. This precipitation, or rain, completes the water cycle within our small enclosed environment. But that's not the strangest part about this simple atmospheric model. The cooler, denser water at the top then sinks, creating a continuous circular motion. This circulation, known as convection, is fundamental to distributing heat and moisture globally. Imagine powerful ocean currents and atmospheric jet streams driven by identical principles. Differential heating within the cup creates pressure differences. Just like in our atmosphere, areas with rising warm air have lower pressure, drawing in air from surrounding regions. This air movement, from high pressure to low pressure, is the very definition of wind. The speed and direction of these tiny winds depend on the temperature gradients present. Observe how even a slight tilt of the cup can alter these delicate internal airflows. This demonstrates how geographical features influence local wind patterns and weather. The amount of water in the cup also directly correlates to the potential for severe weather. More moisture means more energy available for condensation, leading to heavier precipitation. Think of tropical storms drawing immense energy from warm ocean waters. A giant cup effect. Adding a tiny ice cube to one side introduces a cold intensifying front, dramatically altering circulation.
You can literally see the cooler air pushing the warmer, moister air upwards, intensifying activity.
This forced uplift is a primary mechanism for storm development in the real world. The cup's rim acts like a mountain range, forcing air to rise and condense as it passes over. Such simple demonstrations reveal the complex dance of forces shaping our daily forecasts. Wait until you realize the astonishing implications for planetary climate dynamics. This miniature weather system in a cup helps visualize abstract scientific concepts clearly. It reveals why coastal areas often experience more rainfall than inland desert regions. The cup model illustrates how warm ocean currents transport heat across vast distances. It explains why mountain ranges create rain shadows, blocking moisture on one side. Understanding these basic principles empowers us to better interpret weather reports. We can appreciate the immense energy contained within even seemingly gentle weather systems. This simple analogy highlights the interconnectedness of Earth's air, land, and water. It emphasizes how human activities can subtly alter these delicate atmospheric balances. A small change in heat or moisture can cascade into significant, widespread consequences. The warming of global oceans intensifies the cup effect, fueling stronger storms worldwide. Increased evaporation leads to more atmospheric moisture, resulting in heavier downpours. This amplifies the risk of flooding and alters long-established regional climate patterns. The tiny cup becomes a powerful metaphor for understanding Earth's sensitive climate system. It teaches us that even minor shifts can trigger profound, large-scale environmental responses. Recognizing these fundamental mechanisms is crucial for addressing future climate challenges. Our daily choices, like a small breath over the cup, subtly influence the larger atmospheric future. From a simple heated cup, we unlock the foundational secrets of Earth's dynamic weather. Convection, condensation, and pressure gradients are visible, tangible, and profoundly impactful. This tiny, contained world mirrors the powerful, intricate systems governing our entire planet. Remember, even the smallest observation can reveal grand scientific truths about our environment. So next time you see a cup, think about the incredible weather patterns it silently simulates. If you found this fascinating, subscribe for more incredible stories like this every week. Hit the like button if you learned something new today and share your thoughts below.